This topic will be learning about exponents, or people call it power. Okay, so we know, so let me write some notes. Let 3 to the fourth, this is an exponent. Okay, so this actually means, I will be going straight into a problem. This means 3 times 3 times 3 times 3, right? That's what it means if you are to expand it out. This 4 is telling me that this 3 is going to be multiplied itself 4 times, right? Now, let me write this as a note. And 3 to the fourth is read, and we need to learn how to read it as 3, put quotation mark, to the power of 4. We call the number 3 the base, and the number 4 the index, as some books may use it, or power, or exponent. All right, so those are terms which may be used. So let me expand this screen a little bit so you can see it much clearer. So that's what that means. It simply means that anything that you have as a value here, this value here at the bottom is known as the base. This value at the top here, or what you call superscript, if we were to use a computer, it's known as the index, the power, or the exponent. All right, now let me give some more notes on this topic here. If a number, and I hope you guys will copy down these notes, if a number or algebraic quantity, as we will see, quantity, as we will see, is multiplied by itself repeatedly, then we can express it as a base to a power. What is an algebraic quantity? All right, very good. Some of you might be thinking, what's an algebraic quantity? Well, algebraic quantity is simply letters used to represent numbers or values, or just in an expression. Okay, so let me start with some examples. So push this up a little bit forward, and then we can see, for example, if I give you a times a times a, and that goes infinitely to the nth term, then that can be expressed as the base to the n amount of times. This n represents how many a's do you actually have there, I mean the n, and the a is actually the same base because it's the same base that you are multiplying. All right, however, this base a, but a cannot equal 0, right? That base is never 0. It will not work. Okay, so let's practice a few. Let me use that, explain it a little bit. So, examples. Practice. Consider one of them, as we have 2 times 2 times 2 times 2 times 2. If we express that as an exponent, how many 2's do we have? If you said 5, then you're perfectly right. So our base is still remain as 2 and our power here will be 5. Very good if you guessed it that way and if you realize that there were 5 2's. Now let's go with a letter. Consider that we have a letter M times M times M times M times M times M. Well, the base will remain there, which is M. So we're going to write the base M. And how many M's are there? Well, there are 6 M's. Very good. If you see the 6 M's there, then you're going the correct route. Now, consider that I give you a problem like this. Call this example 3. And I say R times R times R, and I put 3 little dots which represents continue repeating that number, multiply it to itself to the nth term or n amount of times. Well, we don't know what is the value of that n, but we know that the base is r, and to how many times did we multiply that r? Well, we multiply to the nth term, which means the n number of times, and that goes up here. So the n is an n number of times, and the base remains as the base. Okay, our fourth example for this topic will be, consider that you have now a letter y times y times y, and you put 3 little dots and then put it to the nth term. So let me pause a little while and see what do you say is the answer. So if you say the base is y, you're perfectly correct. And if you say the power for this one here is n, then you're perfectly correct. So you have covered that topic very good. Okay, so this is what we call exponents, powers, and so forth. Okay, that is our topic for this one here, exponents and power.